Hello everyone. Today I, Sahil and my teammates Atharva and Roshan will be presenting our voting decentralized application using blockchain. It's an app that lets you vote for your favorite candidates, but it's different from the usual voting methods. The voting application uses Ethereum's blockchain which makes sure that your votes are kept safe and can't be tampered with. The key part of this app is a smart contract written in Solidity. The application also has a user-friendly front-end interface made with HTML and JavaScript. Now coming to the components of the application. First is the Solidity smart contract. So uh, first we can talk about the uh, candidate struct which is basically a blueprint for each candidate capturing details like their name and vote count. Next is the candidates array. This is like a list that holds all the candidates with each one following the structure defined in the candidate structure. Then next is the voting function. This function allows you to cast your vote for a preferred candidate, checking to ensure you haven't voted already and then increasing the candidate's vote count. Next is initialization, where the when the contract starts, it gets a list of candidate names and creates candidates with 0 votes. Next is candidate information. You can find out various details about the candidates, such as how many there are and specifics about each candidate. So now we'll be talking about the front end, which is what you basically see which is what you basically see and interact with when you use the voting decentralized application. It is designed to be user friendly and provides you with the interface to cast your vote. The HTML and JavaScript components of the front end include: first is the HTML structure. This defines how the app looks with elements like form for voting, a list of candidates, and a section that shows you the what happened after you vote. So next is the web3.js. So the decentralized application uses this library to connect to an Ethereum node and communicate with the smart contract. Next is the vote submission. So you can easily select a candidate from a drop down list and click a button to cast your vote. When you do that, the application sends your vote to the smart contract. Next is the transaction result. After you have voted, the application gives you feedback letting you know if your vote was successful. And lastly is the initialization. When you first open the application, it basically sets up the list of candidates and shows you how many votes each candidate has. So now talking about the methodology. First is the contract development. So the foundation of the voting decentralized application is the smart contract written in Solidity. This contract is the heart of the system, creating a structure to manage candidates and votes. So it basically includes essential functions for voting, initializing candidates, and retrieving candidate information. So next is the front end creation. To make sure the voting decentralized application is user friendly, a front end interface is designed using HTML and JavaScript. This interface provides a straightforward way for users to interact with the smart contract, making it easy to vote for their preferred candidates. Next is the integration with web3.js. So the application connects with the Ethereum blockchain using the web3.js library. This connection bridges the front end with the Ethereum network, specifically a local Ethereum node known as Ganache. Next is the transaction handling. So after casting their votes, users receive transaction results. These results provide transparency and feedback regarding their vote submission. We can also talk about the user voting process. So users can basically access the app's web page where they can select their chosen candidate and submit their votes. And lastly, we'll be talking about the real-time updates. So the voting application offers real-time updates of the candidate list and the respective vote counts. Now Atharva will be talking about how the application works and its advantages.
So let's look through how the voting decentralized application functions. First, the users visit the application's webpage where they will find a list of candidates. Then they make their choice by selecting a candidate from the drop-down list and proceed to submit their vote. The decentralized application then communicates with the smart contract and executes the vote function. Following this, the smart contract records the vote and updates the vote count for the chosen candidate. Users then receive immediate feedback as the transaction result is displayed, confirming their vote submission. Additionally, users have the advantage of viewing the updated list of candidates and their respective vote counts in real time. This streamlined process ensures a user-friendly and transparent voting system. Now, let's look into the advantages that the voting application has to offer. Transparency. The voting decentralized application harnesses blockchain technology to ensure transparency throughout the voting process. Every single transaction and vote count is publicly visible on the blockchain, providing a high degree of openness and trustworthiness. Security. The decentralized application employs a smart contract that prevents users from casting multiple votes. This mechanism safeguards the integrity of the voting process, ensuring fairness and accuracy. Real-time updates. Users have the benefit of accessing real-time updates on vote counts. This feature keeps them well informed about the latest developments in the candidate standing, enhancing their engagement and understanding of the ongoing process. Now, Roshan would demonstrate the decentralized application.
Okay, so here is the code uh, for the solidity contract, which has the candidate's name, where it collects the candidate's name and then creates a constructor which has the functions of getting votes and then getting the candidate count, like how many votes they have, and then get showing the candidates to the public. And the candidates are deployed as such, like you write the name of the candidate when you're deploying it, like candidate 1 and candidate 2. And then we come to the front end. So the front end is basically a normal HTML front end that has the entire everything, like the smart contract and ABI, which connects it to Web3, and then Web3 connects it to the Ethereum node, which is like the Ganache. And then I have deployed it using Truffle. So when you do like, so when you use Truffle migrate, it deploys the entire, like the initial migration and the deployment contracts to the uh, blockchain, which you can see here in the contracts. So these are the contracts that are made, and then use the contract address in the front end like this. And when you use that, the HTML basically has everything like the info of the blockchain. So when I vote for the candidate one, a vote gets registered and the vote gets updated. You can also see that there was a red line below, which was the deployment address and everything, like the basic transaction affair that was going on, the details about that. But it got like overwritten when the page refreshes, and the candidate one just got a vote. Now there's a thing in this, like one person can only vote one candidate. So if he tries to vote again, there would be an error. But if we go uh, in the code and then edit the account number of the like, let me find it. Like if you go in the code and update the account of the person to suppose one instead of zero, so it's a new person. So now he can so now the new person can vote again. So if he decides to vote candidate 2, the vote will get updated as such. So that is basically the uh, coding and the entire front end part. Now we can talk about the conclusion of the report. The Voting Day app provides a transparent and secure way for users to participate in a voting process. The smart contract ensures that each user can vote only once and accurately tallies the votes for each candidate. The front end interface makes it easier for users to cast their votes and view the results, creating a user friendly voting experience.